Modern science works by wondering about things and where they come from. With billions and gazillions of entities undiscovered in the universe, scientists have started their research with the things they already know about, starting with the most obvious and closest things to James Webb's telescope. The first huge discovery has just been made, leaving everyone in shock. Hey everyone, welcome to Space Scientists. In today's video, we are going to talk about the first huge discovery made by James Webb Telescope. If you want to know more about it, then stay with us until the end of the video. And before we start the video, don't forget to like this video, subscribe to our channel, and ring the bell icon for more amazing videos. After being launched on the Christmas Day last year, the telescope has arrived at its destination after traveling 1,000,000 miles, where it has begun the process of cooling down, calibrating its mirror and instruments, and detecting the first light. And that's another major test for the scientists. First light is an important milestone for any telescope, as it is the point where starlight is detected by the observatory and its various instruments. Through this, the observers can enable a months-long alignment of the telescope. Webb's first light came from a star known as HD 84406. It is a Sun-like star and is located 241 light-years from Earth, and part of the constellation Ursa Major, the Great Bear. Now, if you think that Webb has started taking pictures and began a new era of space observation, then that's not the case. These images are not going to be used for research purposes. Rather, they are going to help Webb's mission control team to align the 18 golden segments of the telescope's 24-foot-wide main mirror. So these images are not the way we expected the telescope to show us, but it's exactly what NASA had expected, and over time, it will be able to adjust two segments to bring the image into focus. NASA Webb Telescope on Twitter posted, "Our NIRCam instruments detectors saw their first photons of starlight. While NASA Webb is not yet ready for science, this is the first of many steps to capture images that are at first unfocused, used to slowly fine-tune the optics." HD 84406 was chosen as a calibration target by NASA because it is moderately bright, located in an isolated area of the sky devoid of other bright objects, and was ideal for JWST's first light. Calibration is now the most important part because it is the part that will lead to some of the best captures from NASA. Now, just as it took time for any other aspect of the telescope, the calibration is also going to take time. This is because of the size of Webb's mirror, which is 273 square feet. But more importantly, the segmented style that consists of 18 individual honeycomb-shaped mirrors that are going to be one large sunflower. When the scientists were performing the calibration of James Webb's predecessor, the Hubble, the iconic observatory that has been operating for 30 years, it was not what we are to witness with the James Webb. Hubble's primary mirror has a total surface area of about 48 square feet, and that's way smaller than Webb. Even though James Webb is going to take time, but it's more reliable than the rickety Schitterian reflector from Hubble. After all, we have come a long way since Hubble was designed in the 1980s. Hubble had a problem with that single hyperbolic mirror, which necessitated a servicing mission to fix an optical flaw. With Webb's adjustable segments, this shouldn't be an issue. Now, over the following 3 months, NASA will nudge each of the gold-coated beryllium panels into place, reducing 18 points of light to one giant sunflower. In an update, NASA said, "The early engineering imagery produced during this stage in the process, called segment image identification, stitches together more than 1,000 images to form 18 unfocused versions of a single star. This serves as the starting point for gradually aligning Webb's mirror segments into one precise system. Once complete, Webb will be ready for its mission to peer deeper into the universe than ever before. But there is something that needs to be attained before the telescope can start its function. The gigantic telescope needs to chill out. As the James Webb is designed to operate in mid-infrared, any errant heat could ruin those observations. So, for this reason, it needs to chill. Webb's equipment, particularly the NIRCam, will operate at extremely low temperatures in order to examine the universe's earliest stars. Because these stars are so far away, the light released by them is only observable in infrared wavelengths. As infrared radiation is essentially heat, Webb must be as cold as possible in order to prevent interference as much as possible. Webb's massive sun shield, as the name suggests, shields the telescope and cameras from direct sunlight, as well as sunlight reflected from Earth and the Moon. Everything on the sun shield's cold side is passively cooling and radiating heat into deep space. This will continue until the telescope and the three near-infrared or near sensors attain a steady-state temperature in which the milliwatts of energy passing through the sun shield, plus heat created by the equipment's own electronics, perfectly balances the heat loss in space. Furthermore, Webb's mid-infrared instrument required much lower temperatures. MIRI will be cooled using a closed-cycle gaseous helium cryocooler or refrigerator to temperatures below 7 Kelvin, in addition to passive cooling. Cooling an infrared telescope is a precise and important operation that ensures that instrumentation's effectiveness and, eventually, the spectacular research. Webb's initial photographs for scientific purposes are scheduled to be released to the public in late June or early July. NIRCam will continue to stare at HD 84406 as Webb's optic specialists reposition the mirror segments in nanometer-scale steps to produce a flawlessly smooth surface. This work is planned to run through the end of April. Only then can the various science instruments begin to properly train their eyes on items in the nearby and distant universe. So, James Webb will need to go through a rigorous commissioning procedure for another 5 months before it can begin working. Bigona Villa, Webb Instrument Systems Engineer at NASA Goddard, in a pre-launch briefing, said, "In total, we will have 6 months of commissioning, a month deployment, 3 months to align the mirrors, and then 2 months calibrating the science instruments." For the time being, the JWST team's next significant milestone, along with mirror alignment, is to finish cooling all the equipment, including MIRI, which will reach its extremely low temperature range by early April. Then, it will be time for what everyone has been waiting for. After Webb completes its 6-month commissioning period, it will begin a series of exoplanet surveys. One such initiative will investigate 11 super-Earths, or worlds, that are between the sizes of Earth and Neptune. In our solar system, there are no such worlds. Along with that, we are going to see the first stars and galaxies that emerged from the dust and gas of the early universe, only a few million years after the Big Bang. Currently, Webb is orbiting the Earth-Sun L2 Lagrange point, which is located beyond the Moon's orbit. This location enables Webb to remain motionless without consuming too much fuel, which is in short supply. Fortunately, NASA currently estimates Webb has enough fuel in the tank to keep it operational for the next 20 years. In conclusion, it is believed that Webb will allow astronomers to look not only farther out in space, but also further back in time, as it will search for the first stars and galaxies of the universe. So we hope that nothing unsolvable comes up, as the mighty James Webb Space Telescope cannot afford to go wrong. And if all goes according to plan, it's going to be an amazing experience for humanity to see the universe with a completely different perspective. The James Webb Space Telescope is going to revolutionize space research, and we are going to get the answers we have been longing for. And this is it for today. What are your thoughts on today's video? What new discoveries do you think will be made by James Webb in the near future? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.